The topic today I'm going to discuss is deep learning application in medical and healthcare. Myself, Adi Manivash. So deep learning is a subset of machine learning. It's comprised of different types of algorithms like linear regression, logistic regression, decision tree, and deep learning being a subset of machine learning comprised of neural networks with many hidden layers. Uh, this Neural networks are capable of automatically extracting high-level features like from raw data and making particularly useful in different domains, like especially in the healthcare. For example, some of the types of deep learning models can be artificial neural networks, which are inspired from the human neurons, convolutional neural networks, mostly used for image and video data, recurrent neural networks. These are some of the specialized neural networks which can mostly applicable for sensor data or data that is dependent on each other. So some of the key areas of application like of these deep learning models in especially in health informatics are translational bioinformatics, medical imaging, and privacy sensing, medical informatics, and public health. So the picture can you show you the some of the applications like you give the like input the DNA sequence or RNA sequence or molecule compounds or protein structure, so which will try to give you the can diagnostic of the cancer or the gene variations it will try to tell you the drug design type and so and so. So the first the translational bioinformatics. So the translation bioinformatics is nothing but it's an identifying nucleotide sequence that bind to DNA or RNA strands, and which is to predict protein structures and analyze genomic data to identify disease markers. Like some of the applications can be cancer diagnosis, like giving an input of gene expression to an deep learning models like autoencoders and making it to diagnosis whether there is a presence of cancers or not. And the next can be the gene selection and classification. So inputting a microRNA sequence for the deep neural networks like belief networks and to classify a gene as a specific category. And then gene variants, like predicting the gene variants, where you try to input micro array of data to a neural networks and making the model to predict the variations of the genes. And the other use case can be the drug design, like specifically giving the molecule compound structures or the combination of compounds or combinations of molecules, which is nothing but the compound to a deep belief neural networks model, so which helps in designing drugs. And apart from that, uh, compound protein interaction, like where you give the input data as like a protein structures to a deep belief networks and telling the model to design a compound protein interactions and RNA binding protection and DNA methylizations. So this all these applications include inputting some molecule structure data or protein structure data or genes type of data to a neural networks, like to get the protein interaction in the compound and all, etc. And medical imaging is one of the it's one of the biggest domain in subdomain in healthcare where deep learning is mostly used. Like for example, if you take like any scanning or CT scans or any EMR images like X-ray images, so like to diagnose whether there is a specific disease or not or a specific tumor or is there any failure in the organs of the body. So with a human eye it sometimes it can be like as a human eye for a human eye it is challenging to able to detect such type of disease, but whereas using the deep learning models where these models are completely like they can go in depth of the data, like in depth of the image analyzing pixel to pixel, even the smaller variations can also be identified by these deep learning models. So medical imaging is one of the such case. Like for example can be uh, like giving an MRI or fMRI images or PET scans and telling to what is the neural cell classification or diagnosis of the specific disease out there. So and giving this data input data to auto encoders or convolutional neural networks or deep belief neural networks or neural networks. And and other can be x-ray images or endoscopic images, uh, just passing through some deep convolutional models, and and making the model to predict whether there is a presence of tumor or not, or whether there is any damage in the specific organ or not. So this can be some of the common use cases which we can work upon the medical imaging using the deep learning. And pervasive sensing, this is like, so in the recent world, like where uh, everyone, like most of the people are accessible to wearable devices which can access your heart rate or your blood pressure, or your exercise activity and everything. And not only this wearable devices, there are other devices like EMR, like it can be some EMR things. So basically, these deep learning algorithms, they process the data from these wearable devices and sensors to monitor the signs in your body, or is there any issue in your body, or and especially like it's going to help every human to monitor their health. Like the basic applications can be like human activity recognition and hand gesture recognition, obstacle detection, and what is how your food intake, like especially in the diet applications, like where you want to make a strict diet but you are unable to control it. Like, but you are, consider you are a mobile phone which tracks you everything, your food intake and everything. So it can tell you based upon the food how much calories you're going to take. So it will try to restrict you, like getting more calories. And the other use case can be medical informatics. Uh, so this is completely related to uh, Medicare and healthcare. So because if you see, the Medicare and healthcare is purely comprises of EHRs, like electronic health records, and which and paid doctors needs to make a decision upon this EHR records. And more importantly, these EHS records are very vast in the size, and sometimes it's very the terminology is unable to understand. Like as a common patient, as a normal patient, where you don't know the terminology, sometimes it will be very difficulties to understand the terminology and uh, to get the information from these records. But imagine using the deep learning models like NLP models or all these uh, recurrent neural networks models, and passing these electronic records to these models and answering, like for answering question answering type, and where those models can answer your questions related to the document. And public health. Public health is mostly concerned about like it's mostly doing analyzing the public health, like is based upon any pandemic or epidemic. What is the chances, like analyzing the where the location or a specific location or a specific region is going to be affected or not affected. So such type of analysis mostly comes under the public health. Basically, it's analyzing the large scale of health to track disease outbreaks and predict epidemic trends and public policy strategies. Like the applications can be predicting demographic info, lifestyle disease, infectious disease epidemics, and air pollutant predictions. Like the information can be some the text messages like the Twitter feed or some Facebook feed or some geotagged images or mobile phone metadata or social media data to deep learning models. So where it can tell specific things like how the lifestyle is changing to the diseases, so and so. Uh, Coming to like discussing about the challenges in deep learnings are very complex models, and being a complex model, they expect a very huge amount of data. So like So when you train your deep learning model with a very vast amount of data that consists of a good quality and quantity of your data, that makes model to get understand all the patterns in your data. So one of the challenge can be the data, providing the good quantity of data with a quality. The second can be computational resources. So running these deep learning models on the CPUs is a time-taking process. As the time increases, your model size increases. So getting hardware like GPUs is the one of the options to be considered, but GPUs are not accessible to everyone, like every individual, because they are cost optimized, cost oriented resources. So it's you need to pay as you need to purchase from the cloud resources like from GCP, Azure, or from AWS. And there can be like if there can be the possibility of overfitting your model, like because the depth, like the complex you design your model, it might make your model to overfit. This is like the most case. So we need to be very particular about defining the model, like how many layers you should take for a specific use case, and how many neurons for each layers, what is the activation function, what is the good loss function, and optimizers, a lot of things. So to especially to validate these deep learning models, you need to have a lot of validation methods, like how you are going to validate your things with the data and especially with the techniques, and integration with the clinical workflows, like whatever the deep learning models you use, and integrating with the real-time applications, which is getting the data, so it needs to pass it and deploying it in the edge devices or deploying it in some cloud infrastructures. It's also one of the like one of the challenges. And future outlook. I think the future of deep learning looks promising with the advancements, because of the availability of the computational power and the availability of larger data sets like from the Kaggle, UCI, and from other government websites, and mostly integration of AI in healthcare systems. Uh, I think so as of now, there's been a great research that's been going on this deep learning, especially in the health informatics sector, as most of the universities and the renowned companies are working together to make the healthcare way more beneficial to everyone. Yeah. So this presentation is completely from the paper named "Deep Learning for Health Informatics." Yeah. Thank you.